I am muted. Fuck my life. There we go. Okay, I'm not muted anymore. And we're live. Okay, welcome to our Engineering AMA, our second one, Engineering AMA 2 Electric Boogaloo. This is Rick, joined by Max Sanchez, JCV, Antonio, Marco, and Joshua. And considering this is an Engineering AMA and not Midweek with Max, I do not have anything to say really, so I'm just gonna kick it over to the guys. So take it away, boys.
All right, cool. So I'll give a quick intro, kind of topics we're going to cover today, and a brief overview of some of the stuff we're working on. And then I think we have a few community questions to get into, and we can also just have sort of a general discussion of some of the engineering work so far in each of these work streams. So super high level, we're covering two topics today. The first is a large conversion to a lot of Rust-based code bases that we're doing at Hemi. So we're moving from opgeth-based our changes on top of opgeth to our changes for Hemi on top of opreth. And so there's a lot of details in there, not just the actual changes from opgeth to opreth themselves and converting those into Rust, but also the Bitcoin indexer that we use, which is called TBC, that's currently written in Go. There's a new version of that called Oxygen, which is built for ZK provability that we're converting over to. And in the meantime, we have a transition plan using a Rust wrapper around the TBC Bitcoin indexer. And for anyone not familiar, that Bitcoin indexer basically acts as a embedded Bitcoin node inside Hemi's EVM. So we have new precompiles in our EVM, which we call HVM, which let you query data about Bitcoin, such as the UTXO table, getting raw transactions from TXIDs, getting block geometry, consensus information, stuff that's not normally available, obviously, in an EVM, or even hard to prove in an EVM using something like a lightweight header-only proof or something. And then the second part of today's discussion will be something that we're currently calling MinerFi. It's going to be rebranded to something a little more general, but basically it's a threshold signature scheme-based system that manages Bitcoin private key generation and key resharing for a secure signing group to handle two components of a overall broader system. The first is a component that quickly allows people to on and offboard Bitcoin onto the Hemi network. And then a second component, which is a DeFi router that lets that Bitcoin be automatically composed into DeFi. So basically the end result of that is someone can register a fixed Bitcoin address. They can send Bitcoin to that, and every time they send it, it gets automatically turned into Hemi BTC and then gets automatically deployed into DeFi strategies. So I think with that, I don't know if anyone else on the engineering team has anything to add to the sort of high level, and if not, we can jump right into the first topic, which is Rust. All right, cool. Rick, I guess we'll kick it off. Any questions specifically about the Rust conversion, or should we just jump into kind of a broad engineering discussion of some of the stuff we're working on, some of the challenges we're overcoming, some of the general architecture notes of interest?
Our questions are adjacent, but not exactly on topic. So if you guys want to start with like a brief overview, then just kick it back and we can get into some community questions.
Okay, cool. Sounds good. So like I previously mentioned, we're basically migrating from an opgeth-based stack to an opreth-based stack. And so for anyone not familiar, geth is the Go implementation of Ethereum, and then opgeth is the optimism variant of that with changes for the optimism ecosystem. And then we have our own fork of that, which has changes for the Hemi ecosystem. And opreth is the same thing, but Rust instead of Go. And so all of the conversion work we're currently working on to enumerate some of the major changes that we made to the upstream opgeth that are getting converted over to opreth. The first one is we have two new transaction types. So the first one is a proof-of-proof transaction. So for anyone not familiar, proof-of-proof or POP is our Bitcoin security or Bitcoin finality inheritance mechanism. So basically people do decentralized publications of chain state to Bitcoin, and then those are used by the protocol to achieve Bitcoin finality, basically timestamping the chain to Bitcoin and then using that for fork resolution. So that requires a new transaction type for the protocol to detect the POP publications of Hemi up to Bitcoin and then incentivize them with rewards that are paid out in Hemi token. And then the second transaction type's a Bitcoin attributes deposited transaction. And this from a technical perspective is a little more interesting and deeper embedded into the code base. What this is doing is it's updating a lightweight Bitcoin consensus node that runs inside of Opgeth, or now Opreth with the conversion, that basically deterministically tracks Bitcoin consensus state based on L2 blocks and allows the chain to have a, again, deterministic synchronized view of Bitcoin consensus across all the nodes on the network. And then that's used to drive that embedded Bitcoin full indexer that I talked about, which is basically indexing all of Bitcoin state in a way that's usable and accessible by those HVM precompiles in order to be able to serve up Bitcoin information into the EVM for people to build interesting new Bitcoin DeFi applications. And that deterministic structure of the Bitcoin attributes deposited transaction makes sure that both the lightweight consensus view and the full index view of Bitcoin is always consistent at a particular L2 block height. So if you just had a connection from Opgeth or Opreth to Bitcoin D, obviously Bitcoin D doesn't index all the stuff we need, but more importantly, Bitcoin D is just going to run on its own and index whatever, process and index whatever new Bitcoin blocks come across the network. And that means that different nodes on the network who are doing EVM execution of a transaction that calls those HVM precompiles would potentially diverge in state, because on one node, even at the same universal wall time, two nodes could have a different view of Bitcoin, which would cause them to answer those HVM precompile queries differently, which would cause EVM execution divergences, which causes a chain split. And so that Bitcoin attributes deposited transaction acts as a synchronization mechanism to make sure that all the nodes on the network for a particular Hemi L2 block have a identical view of Bitcoin for the purpose of those precompiles. And then the other major items or changes that we've made to Opgeth that we're porting over to Opreth is obviously the actual glue for that embedded Bitcoin indexing daemon, the HVM precompiles that attach to that. And then also we are porting over the Geth snapsync protocol to Opreth. So normally upstream Ethereum Reth and also the Optimism fork of it, Opreth, don't have snapsync. So when you sync a node, you have to do a full complete sync from Genesis, which especially for L2s and Ethereum itself, given its long history, are very expensive and take a long time. So we've been porting over the snapsync protocol, the same one that Opgeth uses, to Opreth, so people will be able to quickly snapsync nodes. And I think those are all the major changes. To give a little bit more color on what each person's working on, I've been working on the snapsync protocol porting and the translating the different transaction types. Antonio and Joshua and Clayton have been working on something called Trust, which is TBC in Rust. And so they've been working on the lightweight consensus implementation so that Bitcoin consensus tracking from those Bitcoin attributes deposited transactions, they've been working on porting that over to Rust. And then also their current work is a Rust wrapper for TBC, so keeping TBC or Bitcoin indexer in Go, but being able to interface with it through Rust code without having to use bindings and things that cause a lot of headaches and cross-platform issues. And then the other major component there is Oxygen, which is kind of running in parallel from a development perspective with Trust, and will eventually probably be somewhat merged into Trust, or Trust will be merged into Oxygen, or vice versa. But Oxygen is basically a new version of the Bitcoin indexer that, instead of just indexing the data in standard sort of flat tables, indexes all of the data we care about in a Merkle-Patricia tree structure similar to the Ethereum state tree, which lets us do all kinds of cool ZK provability stuff against it, because you actually get at the top of that tree, you get a state root, which is a cryptographic commitment to all of the indexed Bitcoin data. So not just do all the nodes on the network see the same Bitcoin state, but you can actually prove that a certain HVM query against that state resulted in a particular response, and you can authenticate that against that tree state root, which is useful for lightweight clients, but more importantly, useful for ZK provability. And the other benefit we get with moving from Opgeth to Opreth, which originally we were planning on just building a minimal version of Opreth that ran in sort of a ZK mode, because most of the ZK proving infrastructure in the crypto industry is based around Rust. If you look at all of the ZKVM implementations, almost all of them, I think with the exception of one of them that's not in production yet, by default work out of the box with Rust. Technically, they should be able to run anything that you can compile through LLVM to RISC-V, but in practice, a lot of the conveniences and bindings and all of the testing and everything of the system is around interfacing with Rust code. And so all of the infrastructure for ZK proving things like EVM state transitions, extraction of data from Ethereum DA, processing of that through an L2 block derivation pipeline, all of that existing work in the ecosystem is Rust-based. It interfaces with Reth or OpReth, depending on which system you're looking at. And so being able to reuse a lot of what's already built and battle tested in the industry with our own changes on top of it makes more sense to go with a Rust approach. But we were originally intending for OpReth to just be sort of a ZK-only mode that ran behind a full opgeth node on the network and basically just allowed for ZK provability. But with Optimism's upstream deprecation of opgeth, we're now migrating everything to OpReth so that we're not maintaining legacy code that's not being actively maintained upstream.
And actually, Max, I just want to give one step back as to the whole geth-reth thing, because without the context, it doesn't even make any sense. Why is Optimism switching? How did we even get to this point? Which is, seems almost crazy if you don't think about the way it started. When Bitcoin first started, there was this Satoshi client, this, big C++ thing, and that was it. And then, fairly early on, Marco, myself, and the people who eventually became the Decred crowd wrote a new implementation of Bitcoin in Go, BTCD. And, things were good. There were two implementations, everything's fine. Even though a small team maintaining an implementation is exceptionally challenging. So then when Ethereum started, there were three implementations. There was Geth, which was the one in Go, which was mostly I think it was the Ethereum Foundation that did it. There was it Parity? Was that the original Rust?
Blurs together, I think so, but don't quote me on it.
And then there was the, thankfully forgotten C++ implementation. Eventually, Parity didn't quite work out, and there was Open Ethereum for a while. But Geth, the Go implementation, was where all of the real work in Ethereum happened. And, Geth being this big work had a lot of, there was a lot of baggage, just a lot of things that it was hard to build on. And people tried other things. Open Ethereum eventually died. And there was Turbo Geth, where people were trying to make a faster version of Geth. And that got renamed to something at one point. And then somewhere along the line, people restarted the work. I don't know if it was fully from scratch, but they were still starting basically new with this Reth, a Rust implementation of Ethereum with the goal to be fast. Because Geth was, by this point, this slow monstrosity. And, I like Geth, but it is still a monster. And Reth, that's why Reth didn't have the snap sync that Max talked about needing, or snapshot sync, or whatever it was called. Because at the time, the goal was, it won't need it, it'll be fast enough. And I think we've all gone down that road once or twice where it's okay, are things fast enough, we don't need to worry about this, and then reality catches up with you eventually. But there's now these two implementations, and somewhere around when the merge happened, people in Ethereum started to get into the idea that, well, Geth is great, but we can't have one implementation that's like 95% of the network, and Reth is just this little minority thing. That and just the increased interest in Rust led to more interest in the alternative. And then
misguided.
Yes, it is. I agree. I prefer Go, but a lot of the background, just a lot of the outside world started putting a lot more development time into the Rust thing. And now the L2 ecosystem, starting with Base, then followed by Optimism, have decided they're going to go with the Rust implementation. And could we go off on our own and say, screw it? We love Go, so we're going to stick with the Geth entirely? We could, but the amount of development, just like, as Marco and I learned very painfully with BTCD, the amount of development and effort, and then again, we also learned it with Bitrig, even before that. The amount of development effort it takes to be on a minority fork of something and to go it alone, it's a full-time job for a whole bunch of people. And so that's sort of why this, is the path. I would have had a far less positive sound effect there, Rick. Maybe like the sad trombone or something, but
It's early, JCV, okay? I haven't had sound effects in a solid 2 weeks, so we're warming up here.
I'll also add to JCV's comment about the maintainability. One other thing which I kind of already touched on, but just to clarify, that shifts the needle from maintaining, basically taking on maintenance of opgeth entirely with geth upstream versus, moving over entirely to the Rust-based stack is probably 75% of the work that we have to do for opreth to make it a full replacement for opgeth. We're also already doing for ZK provability. And so the diff is basically from our original engineering roadmap was opreth in just a ZK only mode where it doesn't need to actively sync with the network over peer-to-peer for transaction broadcast. It doesn't need to be a live node that necessarily is keeping up with tip, but rather is deterministically driven based on a sort of driver opgeth node just for the purposes of ZK proving state that's already elapsed. That change set is a lot smaller than just a full conversion if we weren't planning on doing ZK provability for the Hemi network. So we're already doing a lot of the work in opreth anyway. So if they're going to deprecate opgeth, might as well do the remaining work to make opreth a tier 1 node citizen on the network that fully syncs with the network, supports SnapSync, supports Bitcoin peer-to-peer via Oxygen. That's another change that we're in the process of making. So it's a smaller change set than if we were just migrating for purely the purposes of moving over to opreth because opgeth is getting deprecated. We're already doing 2/3, 3/4 of the work just in support of ZK proving anyway. So I guess with that, Antonio, do you want to talk through or Clayton, any of the stuff you've been working on with Trust?
Sure. So as Max said, we kind of had to port TBC, so our embedded Bitcoin node from Go to Rust. And in opgeth, we have both a lightweight version that basically only deals with headers and indexes the headers, and a full node. And Oxygen is basically what the full node is going to be, although it uses different indexing. As Max said, it utilizes a tree, Oracle Patricia tree, which is also useful for all our ZK work. TBC has UTXO indexers and transaction indexers, etc., etc. So what we have right now is Oxygen, which is going to be the equivalent of a full TBC node. And what we're working on is Trust, which for now is the lightweight version. And so we have parity with the lightweight version. Can already be embedded, and we're testing it. And we're also making a version of Trust that basically wraps our TBC node through RPC so that we can keep utilizing it without having to go through all the work of copying the entire database of TBC to Rust. And so for now, we can keep utilizing TBC nodes, but have them be controlled to Trust. So as I said, the lightweight version is pretty much done. Me, Clayton, and Joshua worked on that. And now what we're working on, the next step for Trust, is creating this RPC controller that will allow us to control our existing TBC nodes through Rust and through Trust.
And as I already mentioned, but part of the future roadmap is a convergence between a lot of that Trust work and a lot of the Oxygen work, where eventually the RPC wrapper that we're using for the initial opreth release that basically wraps around TBC, the Go implementation of the Bitcoin indexer, gets replaced by Oxygen, which is, again, our new Rust-based Bitcoin indexer that structures the data differently. So for anyone who's actually running a node on the Hemi network and interested in sort of the deployment stages, the first stage will be the OpReth release that uses the RPC wraparound TBC. So people can reuse their existing TBC data directories, and there's no like large resync or large reindexing of the Bitcoin data required. And then as we continue to test and audit Oxygen, once that's fully production ready, then we'll have a new release that basically enables the ZK features on the Hemi network, the most important being basically committing to the actual state root of the fully indexed Bitcoin state that Oxygen maintains in that Merkle Patricia tree, actually adding that to the Bitcoin attributes deposited transaction, which makes it verified on chain. So you can actually commit that, HVM query, this HVM precompile call with this input data on this this Bitcoin data index, Bitcoin index data tree identified by this state root returns this response to the query. So then you can get the full circle of when you're doing EVM state transition proving in ZK, you can prove, okay, here's all the EVM execution, it hit this precompile, and then you can basically provide a ZK proof of the precompile query against that ZK data tree. So it'll be two steps. The first is this Rust RPC wrapper around the existing TBC implementation that gets feature parity with all of the existing precompile calls and the data they return. And then the second is a new upgrade, which will replace that wrapped version of TBC with Oxygen, which will require either reindexing, or one of the cool things with Oxygen and all the Bitcoin data being sort of folded into this Merkle Patricia tree structure is that you can actually snap sync that structure securely. And so as part of the snap sync protocol, it's not coming in the first version because, again, Oxygen's not going to be in the first version. But with the Oxygen release, snap sync will also support an extension which lets you snap sync that index Bitcoin state in that ZK tree. There's still some tree indexers that are used for tree indexed tables that let you hint certain data for ZK proof calculation or some of the HVM precompile calls. So for example, mapping, TXIDs to containing blocks and stuff like that. But those are a lot more lightweight indexers than reindexing the whole UTXO set and some of the other stuff that's contained in that ZK tree structure. So I guess with that I think mostly covers the current Rust conversion work. I don't know if there's anything else anyone wanted to add to that, because I know we are close to the 30-minute mark. So if there's nothing else or any community questions, we can start moving over to the MinerFi system.
We do have some community questions. They're more general based on both topics and also some other things. So if you want to get into MinerFi first, and then we can save the questions for immediately after.
Okay, that sounds good. I'm just reading through the questions real quick to see if any of them are Rust related. Doesn't look like it. Okay, cool. Well, I'll pass it to the rest of the engineering team if there's anything else on the Rust side they wanted to talk about. And if not, I'll give a sort of overview of MinerFi, and then we can jump over to Marco for some of the stuff he's working on the Continuum daemon, which is part of MinerFi. I can talk to some of the more details about the smart contract side, some of the ZK proofs that we're adding to the protocol overall to make it more secure and allow on-chain attribution and misbehavior, and also talk about some of the public-facing use cases and why we're actually building the system in the first place.
Marco also has a fun assignment for our community that he would like to share as well. So no pressure, Marco, but whenever you're ready.
Sorry, I was reading something, so I missed the last 10 seconds of what Max was saying. What was the question?
God damn it, Marco.
Sorry. I did hear about the assignment, so that one I can do right away.
Okay, perfect.
No, I was just throwing it over to you for the... oh, yeah, go ahead.
No, so I'll just go talk about. So I've actually been working on some ordinal stuff and some taproot stuff in TBC for reasons that I like it and I want it. And actually, the thing that has been bothering me since the dawn of time is that MetaMask is not supporting Bitcoin. Now, they have all the code built into it. They just don't expose it. So I have actually sent in 4 PRs to the MetaMask team to enable Bitcoin as a full citizen. So I'm sure that they have a very fancy marketing reason for not, enabling it. But I kind of don't care. So I think it would be hilarious if everybody here in the community could go like and say that they want those features enabled in MetaMask. So the big motive that I have here is that if MetaMask becomes a full Bitcoin citizen, we at Hemi can use that for real, because now we get some insight into some things, and we can basically use a default wallet that does both, and fun really starts there.
And there's a lot of got to give another layer of detail to what Marco's talking about. From a use case perspective, MetaMask is, as most people are aware, largely EVM based. They do have some basic Bitcoin functionality, but if they enable some of the stuff Marco's talking about, or at least exposed it in a way that we would be able to use it, even if it's not a public-facing, neatly packaged feature in the UI or something, then there's a lot of cool stuff we can do that would allow people to manage. Instead of, like, right now, if you go and you tunnel Bitcoin to the Hemi network through our user interface, you have to connect a MetaMask wallet for your EVM and then a Unisat wallet, or I think we support a couple other wallets that have solid Bitcoin support. I think OKX wallet is on there and works in some limited fashion with some certain types of keys, but not hardware wallets. So there's all this complexity. And if MetaMask supports Bitcoin fully with some of the features Marco's talking about, then the user experience can be a lot better. You can have one key in MetaMask, which could be your hardware wallet, which is not very widely supported in a lot of the Bitcoin web wallet extensions. So from a security side, that's an improvement. But you'd be able to just manage one key in MetaMask, do all your stuff on Bitcoin, all your stuff in EVM chains, and then Hemi at the intersection of Bitcoin and Ethereum, Bitcoin and EVM in general, you would now be able to just have one wallet for all of your interactions with everything across the Hemi ecosystems, whether that's tunneling Bitcoin in or out of the network, or like we're talking about with our upcoming MinerFi system, using our component of MinerFi that allows you to quickly on and offboard Bitcoin without going through the large tunnel system, whether that be doing stuff with ordinals or other meta protocols. There's all kinds of cool stuff that could be done as a single, cohesive experience inside of MetaMask, instead of having this kind of janky, juggling 2 different wallets, having to obviously maintain security of 2 different keys, not being able to use a lot of hardware wallets and a lot of configurations depending on what web extension you're using. So a lot of cool benefits for making Bitcoin or interactions with the Bitcoin network itself related to what you're doing on Hemi a lot easier through just one single wallet interface.
Right, in a wallet interface that actually the Hemi community is familiar with, because I do think that still MetaMask is the big boy around that most Ethereum folks use.
Yep, I think Rabbi's might be a close second at this point, so maybe we'll try to get some Bitcoin stuff in Rabbi as well.
Yes.
Right, well, I do hear quite a bit about Rabbi, but
I've switched entirely. I only have MetaMask around to help people who are still using MetaMask, but
yes, I'm a Bitcoin first guy, so MetaMask is what I use on Ethereum, and kind of gave up on everything else.
But yeah, the landscape of Bitcoin wallets on the web is, well, the fact that we even have to say that sentence is horrifying. But other than that, yeah, the overall state of it compared to MetaMask and Rabbi is terrible. It's just so much less. So no, very cool. Definitely go click, like, once Rick shares those PRs somewhere, if people can click a thumbs up on it or something to help encourage, would be much appreciated.
Right, and actually the one thing that I have done with it at this point is I have created an ordinal through it, and it's signed on it and moved it from one address to another. So I'm able to do real Bitcoin things with those patches in. There's
also some cool stuff we can build on top of that. So if you have actual Bitcoin transaction signing support natively, and it supports Taproot addresses and signing transactions that spend Taproot inputs, there's obviously all the meta protocol stuff that Marco's talking about, but also more generally, one of the things that is it's a back burner item. It's probably a phase 2 part of HBitVM, which is our new ZK-based Bitcoin tunneling protocol we're building. But it's a Bitcoin, we call it MEV marketplace, or a transaction accelerator marketplace, where basically you can pay Bitcoin transaction fees on Hemi using the Hemi token, ETH, USDC, USDT, whatever. And so it creates a external incentive market. So it lets you more efficiently interact with the fee market. You can change fees dynamically. You can write programmatic rules for fees increasing over time to encourage inclusion, stuff like that. But the other cool thing is, theoretically, for people who just want to interact with meta protocols like ordinals, BRC20s, runes, it would let you do all of that without ever actually needing Bitcoin in your wallet to pay fees. So the idea here is, say a ordinals transact. Obviously, ordinals are inscribed to an actual Satoshi, so you need at least that Satoshi in the wallet. But take BRC20s, for example, where you mint them by sending a basically on-chain message that says, here's the token ticker and here's the amount I want to mint. And then you send it similarly with these commands that are just basically data embedded in Bitcoin. Normally, you would need Bitcoin in your wallet to pay transaction fees to do any of those transactions and actually get them included on the network. But with what Marco's talking about with MetaMask, and plus this MEV marketplace, and some magic we're still thinking through on partially signed transactions and some interesting stuff you could do there, you could actually incentivize people to either Bitcoin miners directly to include a zero fee Bitcoin transaction that does your runes or BRC20 transfers or whatever, or you can create a system where somebody else you'd publish basically a partially signed transaction. Somebody else would add a input and an output to that actually ends up paying fees on the Bitcoin network. They would partially sign their part of it, and then that would construct a full transaction you can propagate to the Bitcoin network. And the end result is you as a user never needed Bitcoin in your wallet to pay fees. Somebody else subsidized them, at least from the Bitcoin layer perspective, and then you paid them in, again, Hemi tokens, ETH, USDC, whatever, on the Hemi network. So it allows more of a Hemi native experience, even for doing native stuff on Bitcoin that interacts with those meta protocols.
Yeah, there's a lot of really neat stuff hiding here. And once I had it working, I kind of had, my brain kind of went crazy on what the possibilities are. So I still have not quite figured all the things how we can do with it. But this combined with the broadcast contract and TSS, that smells like a real DAO to me, right? Not a fake DAO. So I really see quite a few things. Cross atomics, true cross atomic swaps that one chain is monitoring another chain inside a contract. That seems like fun, right? So there's a lot of magic hiding in here, despite it seeming relatively trivial.
And there's also, and again, we haven't fully put together a spec for any of this yet, but just kind of theorizing, there's probably also some cool stuff with Lightning, which, again, Lightning hasn't reached the adoption, the Bitcoin ecosystem was hoping for 5-7 years ago. But being able to do those more Bitcoin native transactions, HVM already has the observation of those transactions you need in order to, on-chain verify, opening a Lightning payment channel, verifying the closure of it, responding to that in some way in the EVM, whether that's, transferring assets between, if one party timed out the channel, slashing their stake and giving it to the other user or whatever. So there's like nice sugar you can build on top of Lightning channels already. But with this would give you a much more native way to interact with, at least from a user perspective, interact with Lightning or other sorts of payment channel type technologies directly on Bitcoin itself, where you're not managing this other system to interact with the Lightning network and then observing it through a contract on chain. You could have a full sort of end-to-end user experience where they're holding Bitcoin in their MetaMask wallet, they're creating a Lightning channel, they're signing messages that update the payment channel and are not broadcast on Bitcoin, but are broadcast or at least verified partially, and there's some ZK proof stuff in there that you could use, but verified on Hemi as a way for Hemi to track the state of payment channels in a way that's deterministic and verifiable on chain. So there's a lot of cool stuff with payment channels, meta protocols, BRC20s, runes, ordinals, or even if you want to get OG counterparty and Mastercoin / Omni layer. And
Global
just,
Bitcoins.
Yep. Colored coins.
May still be my favorite Bitcoin project ever.
But yeah, so tons of cool stuff we can do with that, those MetaMask improvements. Some of it we can actually do without it, like Marco said with his working partial demo, but getting those features merged in basically lets us make the Bitcoin native user experience for things that are at the cross section of what's happening on Bitcoin, what's happening on Hemi, makes those a lot easier from a user perspective. So definitely.
Right. And I actually do think there's a secondary thing to that. So once any of these wallets actually gains visibility, then it becomes also a force, right? And the other wallets can no longer ignore it. And so I think that there's a couple of closed modes, even places like Coinbase, where they essentially have these wallets that do these various things for you, but it's all, that's a corporation you have to trust, right? And there's things you have to trust. Whereas if this actually makes it as a first-class citizen, we can really decentralize some things that are not decentralizable today.
Yep. So action item, go like those PRs that I don't know where Rick's gonna post them somewhere.
We're gonna have an announcement going up shortly. Josh was just helping me noodle the wording so that way it sounds engineering and not from me.
All right, sounds like a plan. Cool. So we have about 20 minutes left. We'll probably end up going slightly over. But so the second major topic today is codename MinerFi. We're working on with the marketing team on an actual better branding name for it. But for the purposes of the discussion today, we'll call it MinerFi because that's sort of the origin of it, was enabling miners who are mining at a pool. They're getting Bitcoin withdrawals every day. Letting them easily take their Bitcoin, bring it onto the Hemi network, and compose it into DeFi without them having to go on-chain and, each time they withdraw their Bitcoin, go and connect their Unisat wallet and then tunnel it to the Hemi network and then connect their EVM wallet and then use that to put the Hemi BTC in some sort of DeFi application that they want to earn yield in. So the reason the term MinerFi was originally used for this is that was the inspiration for building it, was let's create a system where people can reserve a Bitcoin address, and then any Bitcoin that gets sent to that gets automatically tunneled onto the Hemi network and then gets automatically composed into DeFi, into permissionless positions that are owned by their registered EVM wallet. So it'd be a one-time setup. You use MetaMask or Rabby or whatever, you interact with a user interface for this protocol, you reserve a Bitcoin address, and then that Bitcoin address you can use for a long period of time, 6 months, a year, or 2 years. And then anytime Bitcoin goes to that, it automatically gets onboarded onto Hemi and then put into DeFi chutes and ladders. And then if you ever want to change how that's done, so you want to say, instead of putting the Bitcoin into this DeFi protocol, put it into this DeFi protocol or whatever, then you could go into the system with your EVM wallet and change how that router is configured. So basically, you set it up once, it automatically onboards any Bitcoin you send to the wallet into the Hemi ecosystem to wherever you chose to put it. And then whenever you want to change that behavior, you're just sending an on-chain transaction to sort of reconfigure that DeFi router. And then eventually when you want to withdraw your BTC, you can go in with your EVM wallet, you own all the positions that were created, and then you can go and move stuff around, withdraw it, do whatever you want. And
I just want to add one thing before you move past it. Remember, normally in Bitcoin, address reuse is bad. Like one of the defining things about wallet security is normally you don't want to reuse a Bitcoin wallet. And so if you're paying attention, Max said that your MinerFi in quotes, we're generating a Bitcoin address that gets used for a long period of time. And I just want to point out that we are well aware and believers in wallet reuse is 99% of the time a bad thing, but there are certain exceptions to that. And so Bitcoin miners tend to use longer lived addresses, and that's okay because it's sort of natural in the way the protocol works for that. And we're trying to fit this in a similar place where we are not reusing an address in the bad way. We're doing it in one of the allowed ways. That's not, we're not compromising security by having a longer lived address, even though usually you don't want that. Just wanted to throw that in there.
Yeah, it's a good thing to mention. And the purpose of the single Bitcoin address registration is exactly that. So it's an easier user workflow of, whether you're mining Bitcoin and you're getting, daily withdrawals that are sent to your Bitcoin address, whether you're using a centralized exchange and, every month you want to withdraw $100 of Bitcoin and put it into DeFi, you're always withdrawing it to the same place. It's set up, it's easy. If you're practicing good exchange hygiene, it's a Bitcoin address that you've already approved with 2FA, and that's part of your, withdrawal whitelist. So for all those use cases, if you're managing a bunch of Bitcoin and you need ideal privacy and you want to be protected maximally from, theoretical quantum computer attacks against, breaking on-chain signatures that you've already created from past transactions, you don't want to reuse addresses. But for this case, it's about onboarding Bitcoin. And the other thing that's important to mention in the system is the addresses are themselves long-lived, but the Bitcoin that gets sent to them is basically transient through the system. And so you're depositing Bitcoin, but it's going into this threshold signature scheme that's quickly sweeping it to an address that is refreshed every couple of weeks with a new, we'll get into all the details, but a new key generation ceremony with new threshold signature operators. And so the address is really just used for transient Bitcoin onboarding rather than, a long-term holding pen for the Bitcoin, if that makes sense.
Well, let me reshare as well. So we do have some address rotation mechanisms built in.
Yeah, and actually, to go into that in a little more detail, so the overall MinerFi system, it's composed of two parts. So there's a threshold signature system. For anyone not familiar with threshold signatures, and if you've been on midweek with Max, you've probably heard me give this explanation like 27 times. But basically, most people are familiar with multi-sig. And so the idea of multi-sig is you have multiple different participants who have to sign a transaction for it to be valid. And usually we talk about multi-sig in terms of M of N. So you have, or N of M. So you have a certain number of participants. You have a group of participants, say 5, and then you need a subset of those, say 3, to participate and sign a message for it to be considered valid. And so back in the original Bitcoin days, to do multi-sig, it was truly verifying multiple independent signatures on chain and part of the spend script that you're encumbering the Bitcoin with. And so similarly on Ethereum with something like Gnosis Safe, or it's now called Safe, very confusing name, but you have individual signatures from each participant that are then verified and counted, and there's a smart contract or something on chain that is counting the number of signatures you have, comparing it to that threshold, and then allowing the transaction to go through only if it's met that signature requirement. And so with threshold signature schemes, what they do is they move that same general setup to the cryptography layer. So instead of needing to have 3 of 5 signatures on chain, you can have a threshold signature scheme with 5 participants where you have the threshold, the T value set to say 3, and then at the end of the signing process that the threshold signature group does, you get one signature that represents basically the combined partial signatures, if you will, slightly technically inaccurate, but the 3 partial signatures of any 3 of those 5 participants, and it produces one valid signature. And so there's obviously efficiency benefits to that, where on-chain you're only validating one signature. So it's on Bitcoin, you're paying for less, the transactions are smaller, so you're paying lower fees. On Ethereum, it's using less gas in the EVM to verify, also lower fees. But more importantly for our use case, it allows what's Marco was alluding to, which is resharing. And the idea of that is, if you look at a Bitcoin multisig, just a standard on-chain legacy multisig, there's no way to change the participants of that multisig. You have, parties A, B, C, D, and E. They each have a public key. And then the multisig, when you send Bitcoin to the redeem script that encumbers the Bitcoin and needs to be satisfied by the script sig to spend it, you're coding in all of those 5 keys for all those 5 participants. in order to rotate those key members or that multi-sig membership, you would need to move the Bitcoin to a new Bitcoin encumbering script that has 5 new keys. And so that's generally fine for a lot of use cases in multi-sig if you don't care about the fees. But for what we're building with MinerFi, again, we want these long-term reusable Bitcoin addresses that survive, for 6 months, a year, 2 years. And we also want a system where the signing of transactions in order to sweep funds from those deposit addresses can be maintained by an ever-evolving decentralized group of validators. We need a resharing system. So if you had, you set it up with the initial 21 participants or whatever, and they all had a public key, and then you create a bunch of Bitcoin addresses based on those public keys, then when somebody leaves the operator set or somebody joins the operator set, everyone would need to get new Bitcoin addresses in the MinerFi system because you now have new participants, which is a new Bitcoin script, which is a different Bitcoin address. Whereas what we can do with resharing using threshold signature schemes is when there's, say, to go back to the example, participants A, B, C, D, and E, and then if E leaves and F joins, we can do a resharing ceremony where the 5 old participants, A, B, C, D, and E, reshare their secret shards of the key to the new participants, which can be the same number, it can be more, it can be less. So in this case, A, B, C, D, F. And then those participants all now control new reshared shards of the same key. So they're able to maintain the same public key. They're able to still spend from the same Bitcoin address. And so we've effectively been able to change the multi-sig group without changing the actual master public key that's being used, and therefore the Bitcoin addresses that are derived from it. And so the overall architecture of the system is we have a bridge component, and then we have a DeFi router component. So the bridge component is where all this threshold signature scheme magic happens. Basically, we have a staking system called VE Hemi that's going to turn into a restaking system to be used for economic security. Participants who have VE Hemi positions, so staked Hemi tokens in this vote escrow system, can restake their positions to participate in different decentralized protocols. So as Hemi evolves, it's going to include the MinerFi system, covenant emulation, and liquidity operators in the HBIT VM tunnel, decentralized sequencing, state root publication, DA, DA publications to Ethereum, some things related to a ZK prover marketplace we're working on, some things for running infrastructure for L3s through our chain builder system. But the first part of that's going to be MinerFi. And so basically participants will stake their VE Hemi positions to have economic stake in the protocol, and then they will become a part of that threshold signature group. And so the system works in epochs. Basically we're currently planning on doing it every 2 weeks. It's going to be either 2 weeks or a month. But every epoch, the old participants will reshare all of the previous epoch keys to the new participants, which means that all of the Bitcoin addresses that people have reserved and are using to deposit Bitcoin into the system, those the private key shards for that will get reshared to the new group. So it lets people come in and out, and it lets the security of the system increase over time as there's more participants with more economic stake, while again maintaining those original Bitcoin deposit addresses that people reserved. And then you get basically a new key every epoch, which is only shared by the participants in the latest epoch who generated a brand new key using a keygen protocol. And then that's used for where the actual transient Bitcoin stored in the system is swept to. So you get this blend of being able to maintain old deposit addresses for easy onboarding of Bitcoin, but also this security reset every couple of weeks that generates brand new keys with only the new operator set. So there's no risk of a compromised set of one of the old resharings, one of the old epoch participant threshold groups being able to reconstruct keys and do invalid things in the protocol. And one of the major things that we're doing to improve the protocol, since we are using it in a very on-chain DeFi native way, is that we have complemented the existing. So there's an existing threshold signature scheme for ECDSA, originally based on the GG18 paper, and then over the years, there's been various security vulnerabilities found in it, and which have been patched, and there's been various improvements made to it. And so we now have a current version of ECDSA threshold key generation, key resharing, and signature generation that's been very well battle tested, very well audited. But one of the shortcomings of it is it doesn't allow on-chain attribution of faults. And so if a participant behaves in a certain way that's not aligned with the protocol, even if in a lot of cases the other peers who are part of that key generation or key resharing ceremony would themselves be able to observe that misbehavior, it's not something that can be validated on-chain and then punished with slashing, have the operator ejected, and then rerun the key gen or key resharing ceremony. And so what we've done is we've added a number of ZK proofs to the key resharing protocol that allow each participant to prove on-chain that they've participated correctly. All of the parameters that are used by the protocol have been generated in a valid way, that they all meet all of the algebraic constraints that need to be met by those values in the system. And so it replaces some of the sort of custom, very large, inefficient ZK proofs that were originally used in the protocol and would be impractical to bring on chain, and replaces those with guest ZK VM programs that validate all those properties and allow verification of all those expectations of each participant's behavior in a compact on-chain Groth16 or Plunk proof. But then also it lets us do additional validations for example, all the peer-to-peer messaging to make sure that each message every participant sends to every other participant is valid data that actually got encrypted and is sent to the right party, was encrypted to the right public key of the remote participant. And so I won't, I know we're running low on time, so I won't belabor the point too much, but basically we've turned the threshold signature scheme from something that relies on standard peer-to-peer misbehavior detection, which can't really be enforced on chain, to a system where the key generation, key resharing, and the fallback threshold signing mechanism are all fully fault attributable on chain. So if anyone misbehaves, either they're not participating when they should be, or they are doing a certain part of the protocol wrong, they're either unable to generate the proper ZK proofs in the first place of their behavior, or that misbehavior, if it's some sort of like a cross-cutting misbehavior of multiple participants, each individually participating correctly, but in aggregate, say, reusing the same end parameter or something like that, that can all be identified on-chain, either directly in smart contracts or by an aggregation misbehavior proof. And so it turns the threshold signature scheme into a system that can be fully on-chain validated. And so if there's any misbehavior by any participant, they can be identified by the protocol, slashed by the protocol, ejected from the validator set, and then we can do new key generation and key resharing ceremonies with the group of participants who are actually behaving correctly and move forward with the protocol. So it basically gives, again, that on-chain verifiability of all participants in the system behaving correctly. And then the second part, which we won't cover in as much detail because it's simpler from a technical perspective, but very interesting from a use case perspective, is this DeFi router component. So basically MinerFi, that first part of the system, lets you reserve a Bitcoin address, send Bitcoin to it, and then convert that automatically to Hemi BTC, which is the version of Bitcoin on the Hemi L2 network. But then the second part is the DeFi router, which when you reserve your Bitcoin address in the MinerFi system, you would also configure the DeFi router for where you want your Bitcoin to automatically be deployed. And so by default, it's going to go into what we're calling Hemi Earn, which is our native Bitcoin staking system that abstracts away a lot of the complexities of earning yield on your Bitcoin, automatically looking for the best yield across multiple different chains, all of that. And so the default would be depositing into that system, but you can also change that configuration and do something else with it. So for example, you could take it and automatically put it in a particular lending protocol, or you could take it and convert a portion of it to stable coins using on-chain DEXs automatically. And so it gives you that ability to stream Bitcoin onto the Bitcoin network just using a single Bitcoin deposit address. And then that DeFi router componentry associates each of those deposit addresses to an on-chain action where the resulting receipt token or similar from depositing it into a DeFi application gets sent to the registered EVM address. So you have this full link between EVM address, Bitcoin deposit address, and then strategy. So you send Bitcoin, it gets put into a DeFi strategy, and that DeFi, the position of that DeFi strategy is owned by the EVM address that registered the Bitcoin address. And then there's also some cool stuff that we've added that's a optional feature for users who want this, where mining pools or centralized exchanges or other parties who are often maintaining or managing withdrawals of Bitcoin for lots of users could be approved in the system as basically a governor of the DeFi router. So they'd never be able to take control of the user's assets, but they would be able to relay a user's signed authorization basically to change where that DeFi router is directing that Bitcoin. So as an example, a mining pool does this kind of full integration. They could provide their users a feature where not only do the users configure their MinerFi Bitcoin withdrawal address, but they could also from the pool interface say, hey, instead of going into this lending protocol, I want to switch it to start going to the Hemi earn protocol instead. And they could do all that from the pool interface with that pool basically being a delegated administrator of that DeFi routing. So still non-custodial. They're never taking control of the Bitcoin. They are just permitted, if you want to use the feature, to direct where that Bitcoin goes in the ecosystem for an easier user experience. And I think John has to drop right at the top of the hour, so I'll throw it over to John if there's anything else he wanted to add, and then we'll throw it over to Marco for some of the sort of low-level tech details on the Continuum daemon, which is part of that threshold signature scheme and how the whole threshold coordination system works.
Nothing for me to add because I got to say my piece on the other parts, but it's been fun. So yeah, thanks.
All right, sounds good. Well, in that case, I'll throw it over to Marco, and also Antonio's done some work on this as well. So I'll throw it over to both of them to chat through Continuum, some of the stuff they're working on that side.
I think you kind of covered it.
Did I steal your thunder?
Yeah, a little bit. Not right. You use more words, so it's better.
Read longer and probably less intelligible, but go on.
No, so actually, the fun thing about Continuum actually to me was the protocol part of it. So it was real fun to write a custom protocol that works over P2P, and then of course Max showed up with, hey, let's do this on chain instead. So we kind of had to throw some of that out. Not really though, so we still keep it as the backup. But I really enjoyed that part, and writing basically and I want to say it looks and feels a little bit like TLS, but it's a much simpler version of that, and it chatters between about 8 peers. So if you have more than 8 peers, somehow your information needs to go elsewhere. And what we did there is pretty cute, is that we send encrypted messages through the other peers to a target. So writing that whole routing layer with TTLs and encryption and signatures was just a lot of fun from a crypto. It's basically a crypto enthusiast's fun box to write. So that was real fun. I really enjoyed that part. And the TSS stuff that we reused from Binance was a bit of an odd beast. It was not badly written. It was just not architected, if that makes sense. So there was a lot of reach around that I spent actually a considerable amount of time on undoing it. So they used a very weird architecture instead of having discrete functions you call throughout all the steps, which is where I landed once I was done. And as is typical with software like that, it had zero documentation, so you had to reverse engineer the whole thing to actually figuring out how it worked. And then there were some fun bugs where they did not support overlapping or non-overlapping participants. So when Antonio ran into that buzzsaw when he started testing it first, where you had Alice, Bob, and Charlie, and then we no longer like Bob, so we kicked Bob out and we had Charlie, and then the whole thing went to hell pretty quickly. So and that had to do the way they derived the public keys and just a random number that existed in the protocol. So there was a lot of very detailed, low-level cryptographic mathy stuff. So if there's any specific questions that are there, I can get into the details of that. But I think that Max has given the the big view of it. Antonio, do you want to add anything to that?
I'll just say that my favorite part, and this was all you, I was just more the validator and rubber ducky, but pretty much on the protocol side, the thing you did with DNS, I thought that was super cool and super fun. So basically, one of the authentication systems was using DNS and custom records, and you can look at the code if it's interesting. But even though it was a slight pain in the ass to test, I thought that was really cool. And yeah, I think designing your own protocol was just very fun to work on.
And also one thing to mention there, the what Marco's mentioning with the Binance. Binance maintains a threshold signature scheme library that we're using and adapting as part of our MinerFi protocol. And so we made a bunch of improvements, refactoring it, like Marco said, to make it so instead of having this sort of tangled up code where you're calling a function, but then it's doing a bunch of stuff behind the scenes with all these channels and internal communication, just refactoring everything into very clear functions that you call. Okay, we're at this step in the protocol, we're going to call this function with these inputs, and we're going to get these outputs, and then we're going to do something with it, and then we're going to call this function. So we did some refactoring around that, but also that library intentionally doesn't handle the peer-to-peer layer. So it's just the cryptographic bits, essentially. And so what Marco and Antonio were working on, part of their work was building out that entire peer-to-peer infrastructure that wraps around all the cryptography provided by the TSS library, but then actually implements peer-to-peer to make sure the right messages in the protocol get delivered to the right participants in the right way. And there's a lot of nuance to that. It's not just flood fill broadcast, plain text messages. There's a lot of nuance for in the TSS protocol. There's a lot of messages that a peer will need to send to another peer, but that should only be known by those two peers, the sender and receiver. And so you got to make sure that that data is encrypted to the public key of the receiver. And so there's a lot of work on the peer-to-peer protocol, just for the different message types and what's a plain text broadcast to everyone in the signature scheme versus what is targeted message to a single participant. And then also a lot of work on, like Marco said, because the threshold signature scheme can expand to support lots of participants, and it's unreasonable to expect that every participant's connected directly to every other participant. How you do routing of messages between peers through other peers in a way that you can still route them correctly. So, peer A needs to send this data to peer C. They have a common connection at peer B. They send an encrypted message that's encrypted to peer C, but through peer B with enough information for peer B to know it's routed to C without knowing anything else about the message. And so building that whole system to actually make the cryptography that the TSS library implements usable in a peer-to-peer network is by no means an easy task. One of those things that it's not just, spin up a standard peer-to-peer library and start sending messages. There's a lot of nuance related to the threshold signature scheme protocol that needs to be respected. And then from the on-chain attributability piece, all of the on-chain messages for the key generation and key resharing protocols, those peer-to-peer messages are done fully on-chain. But for efficiency reasons, we still need that peer-to-peer broadcast for transaction signing. And so not only does the on-chain verification of the quote-unquote peer-to-peer messages as part of the key gen and key resharing protocols need to be fully attributable on-chain, which means that you need to, in zero knowledge, prove that the message you're sending is the correct message, it aligns with your known public parameters, it's encrypted using ECIES to the correct public key of the correct recipient, and then post that message. But also, if there is an issue with the peer-to-peer layer, you need to, for transaction signing, you need to be able to fall back to a similar on-chain verifiable version of that. And so it's not just designing the peer-to-peer protocol and then, ZK proving some stuff about different cryptographic operations. The two are very deeply intertwined for being able to send messages over peer-to-peer and then verify them correctly through the on-chain attributability layer. And then also in the event of, say, a failure in the peer-to-peer network, be able to fall back for resharing, be able to fall back rather for transaction signing to an on-chain version of that peer-to-peer protocol that's also verifiable. So a lot of intermixing between the layers in interesting and sort of non-obvious ways.
Right, and maintaining hard entropy throughout the entire system, that was a challenge, because it looks like you can reuse a value from from one step into another, but that always leads to non-trivial errors that will be found sometime later by somebody. You can't predict
somebody
it, but
else. That's the problem.
yeah.
All right, cool. Well, I think that covers the MinerFi system. So,
No, I think
summary,
there's one more thing. I think we need to make Rick pronounce some of these names of these cryptographers. I think that was part of the challenge, right?
I don't think I have a choice, because in the interest of time, it's now time for questions. So let's see how this goes. All right. Our first question: what system requirements will be needed to participate in the MinerFi consensus system?
That's a really good question. So normally threshold signature schemes are pretty lightweight, and so you could run them on, a basic VM that, go buy a $10 VM. For what we're doing specifically with MinerFi and the ZK proving, that does add quite a bit of computational work to being a participant in the protocol. So to give a couple, I don't have exact specifications to share. We're still working on some optimizations that may be able to get a little lower than what we're currently targeting. But as context, right now the ZK proofs, which is 99% of the computational work involved in participating in the threshold signature scheme, those take about, in aggregate, 10 to 15 minutes to run on a high-end GPU. And so translate that to CPU, it's at least several hours on a pretty decent CPU, and there are timeouts in the protocol for how long you can take to communicate ZK proofs of all the parts of the protocol that you're doing on chain before you get deemed by the protocol as somebody who's not participating. So we're still working on tuning those timeout parameters, and we are still working on trying to optimize the ZK VM guest programs a little bit. So that may drop, but the current sort of target is either a relatively beefy machine, probably something with 8 to 16 modern CPU cores, or a lower end machine with at least like a mid-range GPU attached to it. But again, that may change a little bit because we are still tuning the protocol parameters for how long you have to generate those proofs, and also trying to get those ZK proofs a little bit cheaper, also over time. So right now the system is built around SP1, which, over time, SP1 is going to become a faster system in future iterations. But also there's other ZK VMs that are potentially faster that we could migrate to in the future. So things like, Jolt is showing a lot of promise for being a lot more computationally efficient. Obviously, we're not going to migrate over to it day one. We need to see, something like Jolt run in production for a decent period of time until we're comfortable using it. And eventually the sort of other complicating factor here is we want to migrate to a multi-prover system where you'd actually have to generate ZK proofs for 2 out of 3 approved ZK proving systems. So for example, you'd have to do an SP1 proof, an OpenVM proof, and or a Jolt proof, 2 of those 3, in order for your proof to be accepted on chain to give prover diversity and basically inoculate ourselves against any underlying, under constraint in one of the ZK VM systems, so that while the ZK VM systems will get more efficient, there will be that additional requirement in the future of doing 2 parallel proofs with 2 different ZK VM systems. So quick answer to the question, a relatively beefy machine, either with a good amount of CPU cores or a lower end machine with at least like a mid-range GPU is what we're currently targeting. But we are looking for ways to improve that and optimize it over time.
All right. Let's move on. We have a question coming in from YouTube. April 2026 has already become the worst month for crypto hacks in recent history, with over 606 million lost, including 293 kelped out. Are RS ETH bridge exploit via Layer 0 just last week. And earlier this month, a 285 million Drift protocol exploit. How does Hemi's HVM plus proof-of-proof model protect against the exact attack vectors we just saw in these bridge exploits, such as fake cross-chain messages, oracle manipulation, etc.?
Well, looking at, say, the KelpDAO exploit, for example, and we did also cover a lot of this in midweek, so I'll give the summary version. But basically, the exploit that happened there was due to a one-of-one DVN configuration. So the way protocols like Layer 0 work is cross-chain messages that ultimately allow you to mint tokens on one chain because you claimed that you properly burnt or locked them on another chain. Those messages rely on a group of DVNs, who are essentially oracles for remote chain state, to sign a message that attests to the observed remote chain state. So for example, if you have Ethereum and insert generic L2, and you have a Layer 0 or other Layer 0 style interoperability protocol that you're using, you'll have and say it's an Ethereum native ERC20 that then you added like an OFT adapter to or something. You would set that contract system up so there's a OFT token locker that lives on Ethereum, where the token is native to, and then you have a receiver contract that is able to mint a representative version of that token on the insert generic L2 here. And so when you lock tokens on the L1, you put them into that token locker, and then the DVNs that have been chosen and configured as part of your Layer 0 route, they would observe that the correct state changes on Ethereum have been conducted and that a valid cross-chain message was sent, which says, hey, L2 receiver contract, this EVM address locked 100 tokens, and they should be able to mint 100 tokens on the L2. And then when you unwind it, you go in reverse. So you take the 100 representative tokens on L2, you burn them on the L2, and then the DVNs attest that receiver L2 contract correctly emitted a message that said the correct tokens were burnt. They were burnt by this address. Therefore, this address should be able to reclaim the original tokens, the 100 underlying tokens behind the 100 burnt token position on the L2. They should be able to redeem those or withdraw those from the token locker on L1. And there's also another architecture, which is more of a mesh network, where it's not a token locker, but it's a model where you burn and mint across the networks, but it's the same fundamental security model. And so what happened with KelpDAO was they had a one-of-one DVN configuration, which meant there was only one participant who was signing or authorizing or validating messages between Ethereum and all the L2s where RSETH was deployed. And so the attacker, without going too much into the specifics for the interest of time, but basically the attacker compromised some of the RPC endpoints that Layer 0 was using and observing for, I believe, Unichain, which led them to the attackers basically able to fake Unichain state to make it look like a valid cross-chain message back to the Ethereum L1 contract was created, which would allow the attacker to withdraw a very large amount of RSETH from the token locker on Ethereum. So the attacker was able to fake an RPC endpoint that pretended to be a valid RPC endpoint for Unichain. Layer 0 DVN picked that up and then signed an invalid cross-chain message because of that. There were some more details like the other RPC endpoints that Layer 0's DVN would normally check against for being DDoSed, and so the DVN wasn't able to perform those checks, yada, yada, yada. But fundamentally, it was due to that one-of-one DVN misconfiguration. So from a architectural standpoint, anything that goes through Layer 0 that is either tokens that are native to the Hemi network, like the Hemi token itself and Hemi BTC, their cross-chain components do use Layer 0, but they use multi-DVN configurations, so they're not reliant on a single DVN being compromised. And then more generally, I think the question was also how HVM and proof-of-proof protect against these sorts of attack vectors. So the KelpDAO one, that is Layer 0 specific, so there's not like an exact one-to-one comparison with that exploit and like the kinds of things that the Hemi network as its own L2 with its own native tunneling protocol address. But more generally speaking, what proof of proof does is it gives us Bitcoin finality. So basically you have multiple stages of transaction confirmation on the Hemi chain. So it starts with unconfirmed, it's in the mempool. Then it goes to confirmed, it's in a block that the sequencer created. Then it goes to safe, which means that the block that contains that transaction is part of the DA publication batch that's been published to Ethereum for DA purposes. And then it goes to Ethereum finalized, which means that that publication of that DA batch to Ethereum itself is finalized, meaning you need an Ethereum reorg beyond the finalized point of Ethereum, which is basically impossible. But you need a reorg of that to undo that DA publication of that Hemi chain state containing that DA publication batch. And then the final step is Bitcoin finality, which is when all of that DA publication and finalization has happened, and that chain or a keystone after that point in the Hemi chain has also been timestamped to Bitcoin. And so for fork resolution, it basically goes in the same order of, essentially everything is basically impossible to reverse once it's reached Ethereum DA finalization. But then Bitcoin finality provides that extra additional Bitcoin-based, Bitcoin proof of work-based security on top of it for even more reorg protection. If there wasn't Ethereum reorg, the same blocks could still get republished to Ethereum DA and then still line up with the same previous Bitcoin publications for Bitcoin finality. And so that mechanism basically protects any transactions that are actually done on Hemi from being reverted. And then you can choose as if you're building, say, a cross-chain protocol or something, you can choose what level of that confirmation you want to use before confirming, say, a cross-chain transaction initiated on Hemi to some remote chain that you're using. The other part to that is, so HVM doesn't really play a role in that. HVM is more of a Bitcoin programmability feature. So HVM is around that Bitcoin node that's embedded in the EVM that allows smart contracts to query data about Bitcoin. So you could theoretically use HVM to get up-to-date information about Bitcoin consensus, which in theory you could use in some interesting ways, maybe for a cross-chain protocol that's confirming some activity on Bitcoin to a remote chain. But that's kind of a niche limited use case. So HVM is more around building Bitcoin native DeFi protocols, building things like, our Bitcoin tunneling protocols based on it. You could build a Bitcoin native DEX. You can build cool stuff around meta protocols. And we're going to be adding more features to the HVM in the future that make that easier to do. You could build, actually some of the parts we're building for MinerFi with the Continuum daemon. A more generic version of that could be used to create cool, interesting, smart contract-driven Bitcoin transaction lifecycle management tools. So you could build basically a smart wallet that is controlled by this evolving threshold signature scheme system. And then you're using HVM for the smart contract system on Hemi to observe that certain Bitcoin actions have been taken correctly. But all of those are more like Bitcoin DeFi features, not really security. They benefit from the security of the Ethereum DA publications and then POP publication for Bitcoin finality. But HVM is not directly really a security feature. But the one other thing I'll add on to that too is the work we're doing with ZK provability. So once we launch the full version of OpReth, like we talked about in the very beginning of this live stream, that uses Oxygen as the embedded Bitcoin indexer, that unlocks full end-to-end ZK provability of the Hemi stack. So all of the Hemi transactions between Ethereum and Hemi that go through the canonical tunnel will at that point be secured with ZK proofs. And so there's no operator or group of operators or relying on a challenger or anything like that. It is all purely ZK mathematically driven. We're going to be using a multi-prover architecture, which means you're also not trusting the correct implementation of any one of the ZK VM systems. So, if there is a bug in RISC-0, for example, just picking one out of a hat, then attackers still wouldn't be able to compromise cross-chain transaction proofs unless they found a similar bug which let them perform basically the same execution manipulation of the ZK VM guest program in one of the other supported ZK VMs like OpenVM or SP1. And so I think broadly speaking, as a industry, the goal is to get to, instead of using, in layer 0 actually, with some of the other stuff they're working on with their new chain they're building and some of the stuff they're doing with the Jolt ZK VM, they're also moving towards this sort of an approach in some ways. But I'd say the overall goal for the industry is to move from, trusting a set of DVNs, whether it's one of one, which is a known bad configuration, or, even something better like one required and two of three optional, which we use, for example, for Hemi BTC, moving from that to a fully ZK powered system where there's no subset of operators that could misbehave. All you're trusting is underlying mathematical proofs of remote chain state. And one of the cool things we're doing with HBitVM, which is our Bitcoin tunneling protocol built around ZK, is we are using a combination of Ethereum and Bitcoin consensus security to create self-contained proofs of Bitcoin, Ethereum, or any Ethereum DA-based L2, like Hemi, for example. And so once we have that ZK proving infrastructure in place, that's obviously something that we can use in the Hemi ecosystem, and we will be using for our Bitcoin settlement with HBitVM, which is our new ZK variant of the Bitcoin tunneling protocol. And we'll also be able to use that for the ZK settlement to Ethereum to increase that with Bitcoin's proof of work security sort of natively folded into it. But it also creates an easy technical basis for other projects, other L2s in the Ethereum ecosystem to build ZK proofs of themselves that sort of build on top of those Bitcoin, Ethereum, and Hemi combined self-contained ZK proofs. And so those could be used to build more secure cross-chain interoperability than just sort of vanilla ZK protocols that don't pull in sort of this cross-chain verification where Bitcoin proof of work keeps Ethereum proof of stake in check and Ethereum proof of stake keeps Bitcoin proof of work in check. So there's some cool stuff we're building that's probably a discussion for a whole other AMA. And I think we already did, I know we've discussed it on Midweek a lot. I think we also did another AMA a while ago where we touched on some of the HBitVM stuff. But that's a sort of forward-looking kind of how we want to, what we're doing in the space towards this, full end-to-end ZK provability, but also how sort of that foundation we're building between Bitcoin and Ethereum and reusing both of their security properties to construct this more secure ZK proving basis could potentially be used by other projects to create more secure ZK variants of their own cross-chain interoperability protocols. So long answer, but hopefully that mostly covers it.
I think that covered it. Also, HBitVM would be a good topic for next month's engineering AMA.
Yeah, I think we touched on it in the first one, but we didn't really go deep. So yeah, let's get that on the calendar.
Let's definitely.
That one's fun. There's tons of ZK stuff. So.
Oh Jesus! All right, we will block 4 hours for that one.
Perfect.
Not calling it a happy hour or anything.
It'll start as an AMA and turn into a happy hour at like the 4 or 5 hour mark.
Yeah, totally. For those watching at home, start drinking at any point. All right, I know that you guys have a engineering commitment in 6 minutes, so in the interest of time, I'm going to try to get to 2 more questions if we can try to summarize them.
I will keep it quick.
Okay, and this one actually gives a disclaimer, which is wonderful. It's very on topic. Can you explain what MinerFi allows users to do in 2 to 3 sentences?
Yes. So it lets you reserve a Bitcoin address that then you can send Bitcoin to, whether that's from a pool, a centralized exchange, your own Bitcoin wallet, whatever. And basically everything past you just sending or causing the Bitcoin to be sent to that address, everything else for actually onboarding that Bitcoin into the Hemi ecosystem and then deploying it into DeFi, for example, with Hemi Earn and the Bitcoin staking and yield generation strategies that Hemi Earn abstracts away from you and makes very easy to interact with. It makes that entire process automatic. So I'll give kind of an A/B comparison. Today, if you wanted to go onboard your Bitcoin and then deploy it in Hemi DeFi, you'd have to have a MetaMask or another EVM wallet. You'd also have to have a Bitcoin web wallet like Unisat. You'd have to go to the tunneling page, deposit your Bitcoin, confirm it with your EVM wallet, and then go find the DeFi protocol you want to engage with, connect your wallet to that, your EVM wallet to that site, deposit your Hemi BTC into that protocol, and then, actively monitor that position and see if you want to move it to something else. With a MinerFi system, what you do is you'd once go with your MetaMask wallet, no Bitcoin wallet necessary. You'd reserve a Bitcoin address, which is going to live for at least 6 months, probably closer to a year to 2 years as we do some final parameter tuning of the protocol. But it'd let you register a Bitcoin address that you get to use for a long period of time. And then you configure, hey, whenever Bitcoin hits this address, I want it to automatically go here. Here it could be the Hemi earn protocol that abstracts all this yield generation away. It could be, interacting for more sophisticated users directly with certain DeFi primitives. But basically you'd reserve a Bitcoin address, and then you'd say, whenever Bitcoin goes here, I want it to go to here in the Hemi ecosystem to earn yield. And then once you've set that up, every time you send Bitcoin to that address, it automatically goes through that entire flow without you ever needing to manage a Bitcoin wallet, actually tunnel the Bitcoin yourself, go and deposit into the yield strategy each time you deposit Bitcoin to that address. So it creates that easy flow of, you have a Bitcoin address, and then whatever Bitcoin gets sent to that, however it happens, it automatically gets deployed into DeFi for you. That was longer than 2 to 3 sentences, but I think if you take that last
that's
sentence,
300 sentences.
We'll allow it.
if you take the last sentence, that alone describes everything.
So let me try the one sentence version. It allows you to do Ethereum things with Bitcoin.
Easily with a single Bitcoin address that never changes.
So you're adding already way too much stuff.
All right. Okay. We have time for one more. So let me see. And I apologize to everyone if we didn't get to all your questions. We will certainly cover them on Midweek with Max for the ones that we did not get to today. Are there any new DeFi primitives coming to Hemi that will create aggressive organic demand beyond just standard gas fees?
Yeah, good question. So I'll try to keep this quick because most of the engineering team does have to run in a few minutes. Super high level, yes. So one of the big things we're working on, which I alluded to earlier, is called Hemi Earn, which is this Bitcoin staking protocol that abstracts away a lot of the complexity for you. So basically just deposit BTC through Hemi BTC or other BTC variants as well in the EVM ecosystem into this protocol, and then it automatically goes and finds risk-adjusted, yield-optimized strategies on your behalf. And so that is one of the protocols that will drive demand because that provides an easy way for people to earn yield on Bitcoin in DeFi. And a large portion of that happens as an entry point through the Hemi network with Hemi BTC, this MinerFi system. We're also, the overall architecture of HVM lets people build a lot of cool Bitcoin DeFi primitives. And the things we're working on with HBitVM, I know there's a lot of acronyms, but HBitVM isn't an acronym, but you get the point. Will allow people to, so HVM, you can already build a lot of cool Bitcoin DeFi primitives. HBitVM plus HVM will let you build even more cool Bitcoin native DeFi primitives. And there's a couple that I would like to develop in-house or get the community to build as part of our developer grants and bounty program. So one of those is a non-custodial Bitcoin native DEX. So being able to atomically trade Bitcoin, BTC for any EVM asset through this, whether that's Hemi token, ETH, USDC, USDT, whatever. Basically, any ERC20 you can get on Ethereum or on Hemi, you'd be able to atomically trade that securely with native settlement directly in native BTC. And there's also a variant of a native Bitcoin lending protocol. So being able to encumber Bitcoin inside of a HBitVM style ZK vault, and then being able to borrow positions in DeFi against that and be able to actually liquidate that position with a valid ZK proof of, under collateralization of the loan, things like that. There's cool Bitcoin native derivatives primitives that could be built. So for example, you could write options contracts where, again, you as the person writing the options or the futures contracts, you're maintaining custody of your Bitcoin, but it's going into a ZK vault where it could be pulled out if certain exact conditions are met. So for example, in the case of you writing options, if the option is actually exercised, then somebody with a ZK proof of that option exercise could come back to that ZK vault and redeem the underlying native BTC. But if your option doesn't get exercised, you maintain full control and withdrawability of that BTC after, say, options expiration. So lots of cool DeFi-based primitives you can build either with HVM as it exists today for some like atomic swaps, some cool stuff you can do with smart wallets, to then that expanded set that some of them hopefully will build in-house, some of them hopefully the community will build, that make those more Bitcoin native and ZK powered Bitcoin primitives like Bitcoin lending protocol, Bitcoin native Bitcoin backed derivatives. You could have Bitcoin backed stable coins. There's all kinds of cool stuff with the ZK Vault HBitVM tech that you could also build. And a lot of those, or all of those applications would have direct lock-in on Hemi specifically, because Hemi is the only chain that has the availability of the Bitcoin data you need to actually write the smart contracts that manage the smart contract side of those systems using HVM and Hemi's Bitcoin awareness.
All right. See, that was closer to 2 to 3 sentences.
It was still more, but fewer.
Fewer. It was definitely fewer. But we really appreciate everyone for tuning in today. Thank you for joining us for our second Hemi Engineering AMA. We will be doing this again next month and every subsequent month. Please don't forget to join us for Midweek with Max. Our final Midweek with Max on Discord is happening this Tuesday at 11 a.m. EDT. And then we will be moving over to this platform going forward. We have some exciting community updates on Tuesday as well. I want to just thank the entire Hemi community, the entire Hemi team, and of course our community moderators. With that said, allow me to turn it over to our engineering team for some outros, and we will catch you on the next one.
All right, awesome. Well, thanks everyone for joining us for another engineering AMA. We will be doing these monthly, and I think as we decided live today, the next one's going to be HBitVM, which is pretty timely because once some of this breath stuff and oxygen stuff lands, we'll be focusing on a lot of the other components of the ZK proving system that we need for HBitVM to function properly. So that'll be a good timing to talk about some of those items from an engineering perspective. Really appreciate everyone showing up today, asking questions, listening, and understanding more about our Rust conversion side, which has a lot of interesting tech details for anyone in the space who's curious about sort of the behind the scenes of what actually happens as part of a opgeth getting deprecated and what converting over to opreth. Some of the stuff we're already working on the opreth side for ZK provability, and then also learning about the MinerFi system, how that works from a technical and security perspective, and then also the end user use case motivation of why we're building this and what once we launch it people will be able to do with it. So really appreciate everyone's time, and we will see a lot of you on Midweek with Max. Like Rick said, next week is the last Midweek with Max on Discord, and then it's going to move over to similar to this stream, YouTube, X, and LinkedIn. And so hopefully we'll see you all for the Discord finality of Midweek with Max next week, and we will after that catch you on any of the platforms you're currently watching this live stream on, and also for the engineering AMA that will get scheduled for next month.
Thanks, y'all. Over and out.
All right. Thanks, everyone.
Thanks, everyone.
All right. Thank you so much, everyone. We'll see you soon. Take care. How the hell do I end this, Josh? What do? Hit end stream?